In the world of boxing, there's an old adage that says styles makes fights. In soccer, the saying goes, formations create battles. And in the world of 3D modeling, there's a saying, the right tool for the job. The approach and strategy an artist takes in their 3D modeling project can greatly impact the speed, quality, and overall success of that project. Imagine being a 3D artist who is actively seeking employment and you come across a great opportunity to create a product for an industrial design. Maybe there's an opening at a studio for a game artist position to create items for a video game. Or maybe you get approached by a VFX company looking to hire you to create a hero asset for one of their shots. The real question is, as a beginner 3D artist, which 3D modeling style will you choose to use in each of these different opportunities? With so many 3D modeling styles spread out across so many different packages, choosing the right style for the right job might seem overwhelming. What's going on, you 3D modeling beasts? This is JL Musey, and I'm a professional 3D artist with experience working in film and video games. I've created educational content for companies like Autodesk, and my software reviews have been published in PC Mag. I've taken my decades plus experience and compiled a list of the top 8 3D modeling styles every beginner 3D artist should know. In this video, I'll share personal examples, software recommendations, and even break down the pros and cons of each of these 3D modeling styles. I'll help you level up your 3D modeling skills and make an informed decision on which style of 3D modeling is right for you. Make sure to watch this video all the way to the end, where I'll even reveal the most important and versatile 3D modeling style for beginners to learn. So join me and let's dive into the world of 3D modeling together. In 3D modeling, Booleans refer to a type of operation that allows you to combine or subtract the geometry of two objects. Pros: speed. Booleans can be an efficient and quick way to create complex shapes or make changes to existing geometry. Accuracy. Booleans can be more accurate than manually modeling complex shapes or making changes to that geometry. Very powerful in specific situations. Booleans allow you to quickly add complexity to your model during the blockout stage or help you create intricate cuts or keys in a 3D model for 3D printing purposes. Cons: unexpected results. Booleans can sometimes produce unexpected or inaccurate results, especially when working with complex shapes or non-manifold geometry. Bad topology. It can be difficult to get clean topology from Boolean operations. However, with proper planning ahead of time, much of the cleanup process can be mitigated. If you want to learn my simple process for using Booleans to create complex shapes while getting clean topology, make sure to attend my free hard surface modeling masterclass using the link on this YouTube card or the pinned comment down below. During this training event, I'll cover my Booleans and clean method along with my entire workflow to help you become the great 3D artist that you were always meant to be. Retopology. Retopology is the process of creating a new lower polygon mesh over an existing high polygon asset. This can be useful for a variety of purposes, including optimizing models for use in real-time applications such as video games, reducing the complexity of a model for easier editing, or introducing proper topology to a character to allow for better deformations. Pros: improve performance. By reducing the number of polygons in a model, you can improve its performance in real-time rendering engines or in offline renders. This can be especially important for models with high polygon counts, which can slow down its performance. Faster workflow. Having the bulk of your primary forms established by your initial mesh, retopology can be a great way to focus solely on more efficient topology. This can eliminate much of the back and forth between the concept stage of a model and the technical execution of topology, as the model's primary shapes have already been fleshed out. Improve topology. Working on top of an existing model like scan data or a high poly sculpt will allow an artist to introduce better topology in less time to more models through the process of retopology. This allows artists to go through more reps and improve their topology much quicker using existing high poly models versus creating every asset from scratch. Cons: time consuming. Retopology can be a time-consuming process, especially if you're working with a complex model. It can take a while to create a new lower polygon mesh that accurately captures the details of the original model. Loss of detail. By reducing the number of polygons in the model, you will eventually lose some of the detail present in that original model. This can be especially noticeable in areas of the model with complex geometry or high levels of detail. Sub-D modeling. Sub-D modeling allows artists to create a 3D model using a lower resolution mesh or cage, then preview the mesh in sub-D mode, which subdivides each polygon, producing a very smooth, high-fidelity model. Sub-D modeling is the primary weapon of choice for high-fidelity models within VFX pipelines, as well as high-poly meshes to be used in video games. In order for the hard edges to be retained, they must be creased or alternatively reinforced by adding extra edges known as holding edges. Pros: less working geometry. You'll be able to switch between two states of the mesh, the low res cage and the sub-D preview. Using less working geometry can have many benefits, including better system performance and less dense meshes that can be much easier to UV. Infinite quality. This is the equivalent of a rasterized image versus a vector image. If you take a small quality raster image and you simply increase the size will be bigger, yet it will be very, very pixelated. If you scale that vector up, the quality is infinite. It is a lossless format. This is equivalent of sub-D modeling in the fact that no matter how close you need to get to your object, you will do so without seeing any visible faceting, and this is especially important on curved surfaces. So for example, you could have a hero asset constructed with a sub-D workflow, and this provides endless camera possibilities as you can keep cranking up the divisions on your mesh as the camera gets closer towards that 3D model. Cons: difficulty. You need a high level of 3D modeling skills to create 3D models with surfaces that properly subdivide. This includes developing a good understanding on how to produce quadrant topology, even component spacing, and correctly adding holding edges. Curved areas can be especially tricky to keep smooth and without pinching within sub-D mode if not properly 3D modeled, while flat areas are much more forgiving. 3D sculpting, also known as digital sculpting. This is a method of 3D modeling where you're taking a highly subdivided mesh and you're sculpting details directly on this surface. You could think of this method as using a literal piece of digital clay that you can quickly shape to any form that you would like. Let's look at some of the pros. Organic modeling. This method of 3D modeling really lends itself well for creating organic models such as characters. This digital clay really lets you explore forms much quicker and create characters and anatomy in a package like ZBrush versus using a poly modeling technique in a package like Maya or 3D Studio Max. Concepting. Exploring shapes and design is much easier when you can work with millions of polygons when using a 3D sculpting workflow. This digital clay is much easier to move around and it's a lot more fluid, and you could iterate a lot quicker than having to depend on a traditional poly modeling technique where you have to think about the form and also the topology at the same time to be able to create certain types of details. Skip the technicals. Due to the ability of packages like ZBrush that allow you to work with millions of polygons, it does allow you to essentially skip a lot of the technical barriers that usually have to be learned to create visually appealing pieces of 3D art. For example, you could jump into ZBrush, sculpt details without really having to worry much about clean topology. Ultimately, what this does is make the world of 3D more accessible to artists who are not trained in every little nuance of the technicalities of creating 3D models. Let's look at some of the cons. Processing power. 3D sculpting can be resource intensive and may require a powerful computer to run smoothly. This mesh has to be subdivided to millions and millions of polygons to essentially be able to create that fine detail. You are going to need a somewhat powerful computer to be able to process all these polygons on screen at one time, limited to organic shapes. While 3D sculpting is well suited for creating organic shapes, it might not be as effective for creating hard surface models. I know ZBrush has come a long ways with the Z modeler and a lot of other tools that have pushed hard surface modeling to be a lot more cleaner and precise than in previous iterations of the package. However, for hard surface models, I do like to do the bulk of the work in a primary 3D application like Maya, where I can put a couple of image planes in the background and actually use all 4 views. This is something that ZBrush really doesn't have, is the ability to have true 4 orthographic cameras and be able to actually switch in and out between them. Also being able to fully break down and select one vert using a brush-based workflow. It could be hard to just grab that one component. NURBS. NURBS is a mathematical model commonly used in computer graphics for creating and representing curves and surfaces. NURBS 3D modeling is heavily reliant on curve creation and creating surfaces between those curves known as patches. NURBS modeling is very common in industrial design and is used in CAD applications. For the creation of this custom water bottle holder that I did for a collaboration with Displayland, a photogrammetry app, I used the NURBS modeling application Moai 3D. I 3D modeled the cup holder on top of the scan data of my dash, which I used Displayland for. That's why I chose a CAD application that used NURBS, as this project was more along the lines of industrial design and I needed precise measurements. Pros: precision. It's much easier to create 3D models with exact measurements and tolerances in CAD applications using NURBS modeling. And this is why this style of 3D modeling is the industry norm for industrial design. Curved edges. You can add fillets, which are similar to bevels, to a NURBS 3D model in a CAD application without having to worry about proper topology like you would within a poly modeling workflow. Cons: efficiency. NURBS models may not be as efficient for certain types of models, such as those with lots of small detailed features or creating character models. Compatibility. NURBS models are not compatible with most animation software or real-time rendering engines, which can limit their use. For example, if you wanted to export a CAD model to create a fully textured model for animation into Maya or Blender, you would have to retopologize that model to optimize it for animation purposes. NURBS surfaces tend not to convert well to polygons. Kitbashing. Kitbashing is a technique used in 3D modeling and design that involves using pre-made 3D model parts or kits to quickly assemble a more complex model. The term originated from hobbyists creating custom action figures. The process involved taking parts from multiple action figures and bashing them together to create a new, unique custom figure. Pros: quick details. Using 3D kit bashing can allow you to quickly create a complex model by combining pre-made parts rather than building everything from scratch. Access to a wide range of parts. Many Kitbash libraries offer a large selection of parts that can be used to create a wide range of 3D models. Faster design. By mixing and matching different parts from different kits, you can see what works visually on your model much quicker than creating each part entirely from scratch. Cons: limited control. Because you're using pre-made parts, you have less control over the specific details and shapes of your 3D model. Limited creative options. Using 3D kit bashing may limit your creative options as you are limited to the parts that are available in the kits you are using. Over-reliance on kits. If you are relatively new to 3D modeling and start to heavily rely on kits, this might hurt your growth as a 3D modeler, as you might avoid learning how to model more complex parts yourself. Poly modeling. Poly 3D modeling is a method of creating 3D models by building up shapes by manipulating individual polygons. It is commonly used in the gaming and animation industries for creating complex characters and environments. This is a project that I did as a part of a sponsored series with Autodesk. I was creating this stylized gem to be used as a video game asset. I used a poly modeling workflow to create the low-res mesh that would eventually house the final UVs and textures. Other methods, like digital sculpting, were used in the pipeline to create the high poly meshes. I then extracted all the details from those high poly meshes via the baking of normal maps to then apply to the low poly mesh created using primarily a poly modeling workflow. Pros: it is a widely used method in the gaming and animation industries, allowing for complex characters and environments to be created. Polygon 3D modeling is relatively accessible to most 3D artists, as it can be done with a variety of 3D modeling applications. Cons: Polygon 3D modeling can be time consuming, as each individual polygon must be placed and shaped manually. It can take some time to understand how to create clean polygon models and troubleshoot issues around your poly modeling workflow. Non-manifold geometry, normal, and shading issues are among few of the problems you will have to navigate in order to master a poly modeling workflow. Photogrammetry. Photogrammetry is the process of creating a 3D model of an object or scene using photographs taken from different angles. This is done by analyzing the geometry and spatial relationships between objects in the photograph and using this information to create a 3D model. Photogrammetry is used in a variety of fields, including surveying, construction, architecture, and engineering, as it allows for the creation of accurate and detailed 3D models without the need of expensive or specialized equipment. I use photogrammetry for this cosplay project. I had pictures taken of me from multiple angles and used photogrammetry to create a 3D model of myself. I then used that 3D model as a base to 3D model parts of this Mortal Kombat Scorpion armor. Using the photogrammetry 3D model of myself as a base ensured that all the parts fitted my body accurately once they were 3D printed. Pros: this method allows for the creation of 3D models in real time, making it useful for on-site inspections or construction projects. Photogrammetry can be used to create 3D models for large or complex objects that may be too difficult to measure or scan using traditional methods. Photogrammetry allows for the creation of 3D models in real time, making it useful for on-site inspections or construction projects. Cons: photogrammetry requires a large number of photos to be taken from different angles, which can be time-consuming. The accuracy of the 3D model may be limited by the quality and resolution of the photos used. Photogrammetry may not be suitable for creating 3D models of objects with highly reflective or transparent surfaces, as these surfaces may not be accurately captured in the photos. We're coming towards the end of the video, and every single 3D modeling style that I've shared is tremendously valuable in the right situation. But if you had to twist my arm and ask me, JL, which style as a beginner do I need to start learning today? And the answer is subdivision modeling, also known as Sub-D modeling. Sub-D modeling is a powerful and versatile 3D modeling technique that is particularly useful for beginners to learn. It allows you to create highly detailed models that can be easily modified and adapted for use in a wide range of industries. To illustrate the versatility of Sub-D modeling, let's take a look at this example of a neck armor piece that I created for a 3D printed bust of Apocalypse. It's that big guy right there in the corner, by the way. I started building that neck piece armor using a clean Sub-D workflow, which allowed me to use the same asset in multiple ways. First, I used a subdivided mesh as a high poly version of the model. Then by stripping away the holding edges and doing some light optimization work, I was able to create a low poly mesh suitable for real-time rendering. So from that clean sub-D model, I was essentially able to create the high poly, and then with a little bit of optimization, I was able to create the low poly as well. At this point, I actually wasn't done as I wanted to 3D print that model. So I applied a smooth, essentially baking in that smooth resolution, and I exported that neck armor as a STL file for 3D printing. So with a little bit of sanding, with a lot of sanding, I was able to achieve a smooth, professional quality finish on that final 3D print. So with this example, you can see how sub-D modeling is an essential skill for any 3D artist to have in their toolkit. Whether you're just getting started in the field or you're an experienced pro, it's a technique that will serve you well for a wide range of projects. So if you're looking to improve your 3D modeling skills, I highly recommend focusing on sub-D modeling as your starting point. So what are your favorite styles of 3D modeling? Did most of these make it on the list, or did I miss some? I would love to hear your feedback in the comment section down below. That's all the time that I have for you folks. Thank you so much for tuning in. And until we meet again, I will catch you next time.